Hi, in this question, as you see that this is a graph between the brightness and the wavelength, okay, and we have to find out the temperature of the black body. Now remember that we can consider, and even in the past papers you will see that sometimes they will say the planet surface is considered as a black body, or certain surface or the surface of earth is considered as a black body. So black body, when we consider something black body, it means that it is radiating 100% of its energy in the form of all electromagnetic spectrum, okay. So if I am considering this black body, so it means that it will radiate, in fact, with maximum energy, the green light. And why I'm saying only green light? And because according to the graph that you see in the question, right? If we see exactly the peak wavelength, dear students, the peak wavelength is 5 micrometer. Okay. So the 5 micrometer means that it is 500 nanometers. And 500 nanometers electromagnetic wave seems appear green light to our human eye. So this is a green light. So it means that this electromagnetic spectrum shows us that the black body is radiating green light with maximum energy. Okay. So in this question, we have to find out what is the temperature at of the black body, okay? Because every curve is made at a certain temperature. When you will change that temperature, according to Wien's law, we know that the peak wavelength times temperature in Kelvin is equals to constant. So when you will alter one quantity, the peak wavelength will also change. And when peak wavelength will change, this curve will change. Either it will flat more or it will go even more like this. Okay, so let's find out the temperature of the black body. So that is easy. The temperature is equals to, and this constant is, dear students, 2.9 times 10 power negative 3 meter Kelvin divided by what is a peak wavelength, that is a 5 micrometer 10 power negative 6 meter. So the temperature at which this graph is made, or the temperature of the black body, is, okay students, so that is 580 Kelvin is the answer for the part first. Okay, let's go to the part B, in which they say the Kelvin temperature of the black body is doubled. Okay, remember, if you are increasing the temperature of the black body, it means now it will radiate more energy, okay, more joules of energy and more intensity of light. So it means that if it is radiating more heat energy, more thermal energy, which means that the peak wavelength will reduce, and which means that now the light that will carry maximum energy will have wavelength less than 500 nanometers. Okay, so violet, indigo, blue, green, yellow, orange, red. So if you go back from the green light, violet, indigo, blue, green, so either this light will be blue or indigo or violet, or it can even be in the upper spectrum, invisible spectrum. I'm talking about ultraviolet, x-rays and gamma rays spectrum. Okay, so let's find out this. And of course, once again, dear students, we will apply the same formula. What we have done, we have increased the temperature 2 times, and peak wavelength will change, in fact, so, and that is constant. So what will be the new peak wavelength? That will be equals to 2.9 times 10 to the power negative 3 meter Kelvin divided by 2 times 580 Kelvin. This will give us a new value of peak wavelength. Well, increasing the temperature 2 times will simply mean that the wavelength will get half. So that is 2.5 micrometer. Okay, so which means that it is 250 nanometer. And remember that our visible spectrum, violet, indigo, blue, green, yellow, orange, red, starts from the violet, that is 400 nanometer, and the red has a 700 nanometer. So dear students, it means that first of all the wavelength has decreased, and now Well, if I try to draw here, this is our previous curve, okay, something like this, in which you know that this is a peak wavelength that was, remember what was the value, 5 micrometer. And now, dear students, important point is that why I'm drawing it in the separate graph, because I want to show you that now we will have first of all more area, okay, and it will be something like this. What I'm trying to show you that not only the peak wavelength has reduced, okay, that is 2.5 micrometer. Important point is that, dear students, you see now it is covering more area under the curve. That is important thing that I want to show you actually. More area means now the black body at the twice temperature, okay, is releasing or propagating or radiating more thermal energy, electromagnetic wave energy, okay. So students, last but not least, what, let's see what they say in a question C. They say if the area of the body is reduced but the temperature remains constant, okay. So well, of course, if the temperature is constant, okay, in the A temperature was 580 Kelvin and peak wavelength was 5 micrometer. If the temperature is same, now I will draw the same, I mean something like this, okay. You see it has a same peak wavelength, because if the temperature has not changed, peak wavelength will also not change, and reference is this formula we see, Wien's law, right? But they ask what does the area represent. Remember now, if we let's try to multiply the quantities on the y-axis, because remember that the area is equals to, in general, the quantity taken on y-axis times the quantity taken on x-axis. Just like you know, the area under the velocity time graph is equals to displacement, all right, okay. So if I overall, if I just want to know that what is the area representing, so I should multiply the units, okay. So that is watt per meter cube, I will multiply it with meter, okay. So if I multiply in terms of unit, watt per meter cube with meter, so what I'm getting is the watt meter per meter square, which means that is a power over area, or according to our new curriculum you can say luminosity over area. That is, don't you think, apparent brightness? So in other words, this area represent a quantity that we know is the apparent brightness. So how much energy is released per second per unit area? This is what the area conceptually means. I hope you understand this whole question.